What you're doing in the results section is you're interpreting the data that you collected. Data are not equal to results. Data are the raw data points that you collected, and you analyze those by fitting a curve, or by using some software algorithms, or by calculating means and standard deviations. And so you've converted those data into results. Interpreted data equals results. So you have put some meaning onto the data. Now, we don't want to go into the discussion section and the results section. What's the difference between interpreted data and discussion? Well, interpreted data is looking at it in the context of the objective and the procedure that's being done. When you interpret those results to the context of other research that's already been done, or into the context of the research question or application, that is interpreting results to make a discussion point. So this might be new information for some of you. When I've told my students that data and results are not the same thing, they were pretty surprised by that, and they'd never thought about it before. So don't use these terms interchangeably. They don't mean the same thing. So one thing that is typically difficult for students is describing their results. And they have a lot of trouble describing their results without repeating the data. So how can you describe your results? What kinds of things should you be looking for? One kind of result that you can pull out of your data could be a general classification, such as the phenotypes may be divided into 3 main categories: dark green, pale green, and chlorotic. You can also make comparisons and contrasts. Mice in X treatment were twice as large as mice in Y treatment. You can also describe trends. After treatment began, there was a sharp decrease in survival, followed by a plateau. Also, you can describe high or low points. Growth rate peaked at 21 days after pollination. So these are all kinds of different ways you can pull results out of your data. Some additional ones are describing ratios and proportions. Plants with high nitrogen treatment had 125% higher yield, or phenotypes for flower colors segregated in a 3-to-1 ratio. You can describe fractions, such as 30% of the plants survived the drought treatment after 3 weeks. You can describe averages. The mean grain iron concentration was 35.6 micrograms per gram across 299 lines. You can describe ranges. The grain iron concentration ranged from 19.5 to 67.9 micrograms per gram. You can also describe causality. The plants with a mutation in the FIFI gene failed to induce FRO1 gene expression, or higher nitrogen supply led to increased growth. So those are all type of descriptions that you can try to make, and there's probably other ways. All right, here's a question for you. Fill in the blank. Simply restating data from a figure or table is not presenting a result because of why? What do you think? If we look at this figure and we have this sentence in the results section, grain yield was 2.6 grams per plant for wild type and 3.6 grams per plant for the RNAi line at 18 milligrams nitrogen supply in the optimal environment, and about 0.6 grams per plant for both lines in the heat stress environment. So this sentence is simply repeating the results from the figure. They're not giving us any information that we can't see ourselves if we just look at the figure. It's repeating, right? It's not interpreting. So how would I fix this? So I would revise this sentence by saying, grain yield per plant was significantly higher for the RNAi line at 18 milligrams nitrogen supply in the optimal environment. However, yield for both lines was decreased by 8 to 10-fold in the heat stress environment. So I've done 2 things there. I've done a comparison between the 2 lines, and I've also looked at a proportion or a fold change between the treatments. So I've interpreted this data in the context of the experiment.